is taking these polynomials, adding them, subtracting them, and multiplying them. Folks, this is Algebra 1 review. I'm guessing as we get into this, you'll even remember it. You know, I always say I'm always going to reteach everything, which I'm still going to do. I don't necessarily expect you to remember it. I think you'll remember this stuff as we get into it. You'll be like, oh, yeah, I know what I'm doing here. Okay, so the first half of the lesson is adding and subtracting polynomials. In order to add and subtract polynomials, you guys know the drill. What do we need to do? We need to look for like terms. Okay, in order to add and subtract, we are adding and subtracting like terms. In order for terms to be like terms, I've got it up here in words, the variables and their corresponding exponents must be identical. So remember, you can add x's with x's. You could add y's with y's. You could add x squareds to x squareds. You cannot add x's to x squareds. Okay? So not only does the letter have to be the same, the exponent on that letter has to be the same. So let's look at A. We have 6x cubed plus 4x plus x squared minus 7 plus 2x cubed minus 8x squared plus 3. Okay? Now, the parentheses on this problem. Do the parentheses really mean anything on this problem?
No.
Not a whole lot, because what type of problem is this? This is a adding problem, yes? So when it comes to subtraction, okay, it means a little bit. But with addition, it doesn't really mean a whole lot. You're adding whatever's in the first parenthesis with whatever's in the second parenthesis. We're looking for like terms. So with that in mind, what do you see?
The x squared and the x cubed.
Okay, let's start with x cubed. You've got it on the paper in front of you. Okay, there's what? What's 6x cubed go with?
2x cubed.
And what is 6x cubed plus 2x cubed?
8x cubed.
8x cubed. Okay. Then he said something about x squared, yes? What do you see in the way of x squareds?
X squared minus 8x squared.
Okay. A positive x squared and a minus 8x squared, which really means we're doing what?
Taking away 8.
Yeah. Taking away 8 from 1. In other words, what's the invisible number here that we all know? 1. And so 1 plus negative 8 is?
Negative 7.
Negative 7. So minus 7x squared. What else? What about the 4? There's a 4x. Do we have any other plain x terms that goes with?
No.
No.
Just drop.
So we just drop it into your answer. Is that what you mean? Yep. We're going to drop it into the answer there. Don't forget it. You can't drop it out of the problem.
No.
We have to drop it in the answer. Don't forget it. And finally, what else? A minus 7 and a plus 3. Minus 7 plus 3 is minus 4. And guess what? You're done. Okay?
Light word.
I agree. Okay, as I said, I always say I'm going to reteach stuff, and I am, but do we remember? This stuff we remember, don't we?
Yeah.
There might be some pieces that like, oh, I'm glad you retaught that, I forgot that, but for the most part, I think you guys are going to remember this stuff. Okay, let's look at B. What do you notice about B?
It's a subtraction.
It's a subtraction problem, yes?
Yeah.
That's important, yes? Okay, so you have to pay attention to what sign is in the middle there, because that means that everything in the second parenthesis is being subtracted. Now, I don't know, do you guys go through and rewrite this, or do you just look at it as is and do it?
I just look at it.
I just do it.
Okay, and I'm fine with that. When I talk about rewriting it, if you want, you could rewrite this all out and what? Since it's subtracting, change all the signs in the second parentheses, yes? Okay, so what do you see in the way of like terms to begin with?
3x.
X squared, y squared.
Okay, We have x squared, y squared. 3x squared, y squared goes with 2x squared, y squared, and we get what?
Yeah.
1x squared, y squared?
Yeah.
Because it's going to be 3 minus 2 is 1x squared, y squared, except notice what I wrote on my board, I just wrote x squared, y squared, yes?
Yeah.
Can you write the 1? You can. I'm okay with that. I don't know if Savas is okay with it, sorry to say. Okay, so don't put the extra ones in there is my recommendation. Okay, what else goes together?
X, Y squared.
Okay, an xy squared term goes with an xy squared term. And what are we doing here?
And,
2
oh, yeah.
minus 3. 2 minus 3 is negative 1, so I'm going to write this as minus xy squared. Okay, and we have x squared terms that go together. What do you know about your x squared terms? What'd you say?
One of them is positive, one of them is negative.
Uh-huh. So what are we doing here?
Adding.
It ends up being 6 minus negative 2, doesn't it? And so as several of you have indicated, you do end up adding. 6 minus negative 2 ends up being positive 8x squared. Anything else? No. You're done there. Are we good? Okay, let's keep moving. What's next? What do you notice about C?
A cubed. What's it's an adding?
Okay, it's an adding problem. Always want to pay attention to what sign is in the middle. Okay? Because in homework, they're going to mix it up on you, aren't they? Okay, where do you want to start?
A cubed.
He says start with A cubed.
Well, just drop the 4A.
Okay. Officially, I try to go in order of highest exponent to lowest exponent. The first thing there's a 4A to the 4th, and there's no other A to the 4th, are there? So 4A to the 4th just carries down by itself. Then he wants to go A cubed. What do we have in the way of A cubes?
Negative 6A cubed and 5A cubed.
What is negative 6A cubed plus 5A cubed?
Negative A cubed.
Minus A cubed. Next.
3A, negative 3A squared, 7A squared.
And negative 3A squared plus 7A squared is going to be
Positive 4A squared.
positive 4A squared. Next.
A and 2A.
This is too easy. A and 2A.
3A.
1A plus 2A is 3A. And lastly,
Negative 1.
1 plus negative 2 or 1 minus 2 is negative 1. Okay. And D. What about D?
So subtracting.
It's subtracting. Mrs. Sargent had a pattern, didn't she?
Yep.
But key is watch, right? They're going to mix them all up in class. They could even have multiplication thrown in the middle there. So, okay, what do you see? Okay, we have A squared, B squared goes with A squared, B squared. And what are we going to have?
Negative A squared, B squared.
Okay, 2 minus 3 is going to be negative 1, so negative A squared, B squared. Now what?
A squared, B. Or would it be that?
Or would it be
I assume so because the A is going to be squared. I don't know.
I don't know if it matters what you do next. Because what do we have left? We have AB squared and we have A squared B. I don't know what the proper order is here, officially. Okay, so I don't really care which we do next. Pick one and go with it.
AB squared.
He says AB squared. Okay. So what goes with 3AB squared? 7AB squared. And what are we doing with this 3 and this 7? We are subtracting. So what are we going to get? Good. Minus 4AB squared. And the last piece. Okay. And what are we going to get there? Good. It's -5 minus -9. And so that does become -5 plus 9. So plus 4A squared B. Okay. We got the basics of adding and subtracting down, yes? Look for those like terms. Exponents have to be identical. Okay? Be careful as you do that, right? Now, what's in the next section? Multiplication. We're going to save division for another day. In fact, I think division might even wait until after fall break. Okay, so we got add and subtract. We're going to do multiply now. Now, first of all, some thoughts. To multiply polynomials, officially it's the distributive property. And then it's a matter of after you multiply, so after you distribute, then we're looking for like terms and adding and subtracting them again, right? Same thing as above with the like terms. How do I know that these are multiplication problems as opposed to addition and subtraction problems?
There it is.
Yeah, my parentheses are butted up against each other. That's an assumption of multiplication, right? So, just because they're going to mix them up in homework, aren't they? So you have to watch carefully so you don't do a bunch of work where you don't need to. Okay, so on A, 2m plus 5 times 3m squared minus 4m plus 2. I'm jumping right in. I'm not going to go with the small basic ones. If we're multiplying, what are we doing?
Like the 2 goes to all 3 on the next one.
Yeah, this 2m goes to all 3 pieces. And then after that 2m goes to all 3 pieces, then what? The 5 goes to all 3 pieces. Everything in the first parenthesis multiplies with everything in the second parenthesis, right? Okay, so 2m times 3m to the second becomes,
6 times 2.
are we good there? 6m to the third. You're multiplying your coefficients. 2 times 3 is 6. And then what are we doing with our exponents? We are adding them. Does this sound familiar?
Yeah.
Okay. Continuing then. 2m times minus 4m. Minus 8m to the second. Good. 2m times 2. Plus 4m. Now I'm going to move to the 5. I'm going to keep going. 5 times 3m squared. 15m squared. 5 times minus 4m. Minus 20m. I need to start writing smaller, yes. And lastly, 5 times 2 plus 10. Am I done? No. What are we doing? Looking for any like terms. What do we see?
We can bring down 6.
Okay. 6m cubed is going to come down as is. It's my only cube. Minus 8m squared is going to add to 15m squared, which is minus 8 plus 15 is 7m squared. And 4m goes with minus 20m. 4 minus 20 is minus 16m. And don't forget, bring down the plus 10. Good. Okay. Yes, there's work there, but are we good? I heard good things coming from behind me, so. Well, let's try B then. We're going to distribute. Six into the second times into the second.
6 times the power of 4.
Good. 6 into the fourth. 6 into the second times in.
6 into the third.
6 into the third. And 6 into the second times 3.
18 to the second.
18 into the second. And what else am I distributing?
-7.
A -7. Good. Note it's a negative. -7 times n squared
-7
-7n squared. -7 times n -7n. -7 times 3 -21. And do we have any like terms?
Yeah. The
18.
second.
Okay. My n squareds, right? So we're still going to have 6 into the fourth plus 6 into the third. 18 minus 7 is going to be 11 into the second minus 7n minus 21. Good. Okay, what about C?
So you just put it in the same thing in another parentheses.
But you just, yeah.
So officially, my recommendation is that you, before you start, you rewrite this out as 2 parentheses. Because when that's a squared, it means we're doing parenthesis times parenthesis, right? And the common wrong answer there is to just say, oh, it's 49 into the fourth plus 9. You're missing the middle terms then. Okay, so do me a favor, write it out, and then let's distribute. Or, I don't know, do some of you maybe think FOIL here? That's what it is also, right? Distribute or FOIL, same idea. So, let's go. 7m to the second times 7m to the second. Okay, the math isn't that big. I lost everybody. Okay, 49m to the fourth. I'll take that one then. 7m to the second times minus 3. Minus 21m to the second. Then I'm going to distribute my minus 3. Minus 3 times 7m to the second. Minus 21m to the second. Minus 3 times minus 3. Plus 9. And what happens?
Yes. The 21s cancel out.
Not exactly.
Oh wait, no they don't. My bad. Hold on.
Okay.
My math is not bad today.
Okay, so 49m to the fourth carries down. Braden demonstrated the common mistake for us. Thank you. Okay. And that's the thing. He did it here. How many of the rest of you did it without saying it, or you're going to do it in your homework? It's going to happen. So learn the lesson now, right?
You fail your test because of that, you know.
I guess I look at it this way. Better you guys make the mistake now than in homework or on the test, right? So, okay. Negative 21 minus 21. Those are not opposite signs, so they don't cancel. So minus 42 m to the second, and then the plus 9. Okay. Now, what about D?
I say we just skip that one for the day.
What the heck? There's 3?
There's 3.
You just have to like put
Yeah,
the
for
mn
extra long
times
or
mn times 2 times mn times 4 and then do the 1. You just have to like distribute that.
What? Yeah. Didn't you just say?
I don't know.
You
how to
distribute the first two, and then once you get the final answer on those, you do it to the third one.
I like that idea.
Oh, that makes sense.
So pick two to start with. I'm going to start with the first two. It doesn't matter, right? Pick two to start with. Multiply those. I'd go ahead and clean it up, get that final answer, and then multiply in the third one.
Bang.
Okay? So, now let's see how we do with this. Mn times Mn.
In squared.
Is it m squared, n squared?
M squared, N squared.
Oh, alright.
Mn times minus 2.
It's negative 2 and
Minus 2Mn. Then distribute your 1. 1 times Mn plus 1Mn, or Mn. 1 times negative 2. Negative 2. Now, because I still have more multiplying to do, I'm putting that whole thing in parentheses. And then I'm just carrying down the Mn plus 4.
I said,
Well, and that's the thing. I'm just carrying this down right now because I don't want to forget it.
oh, okay.
And if I don't write it down right now, I have the tendency I might forget about it and not come back and multiply it in. I would agree. Let's clean up this first one first. Less terms multiply if we clean up now. What do we know about negative 2Mn plus Mn?
Negative.
Negative Mn, right? Because it's negative 2 plus 1. So I'm going to have m squared n squared minus Mn, or minus 1Mn, minus 2 times the Mn plus 4 that I don't want to forget, so I keep writing it down. And now
Now we distribute.
we distribute again. Okay? If you're someone that's more comfortable, could you distribute from the back?
Yeah.
If you'd rather distribute the smaller parentheses, which is normally my preference, you could do Mn times each of the first 3 and 4 times each of the first 3. Or we can distribute as is. What's m squared, n squared times Mn?
M squared, n squared. No, you're gonna add it, right? Is it mn or m cubed, n cubed?
There we go. We got it.
Bro,
You got it.
yeah, I knew what I was trying to say, but couldn't say it.
M cubed, n cubed. Okay? What about m squared, n squared times 4?
4 m squared.
Or m squared, n squared.
I don't think mn should be together.
It is a tongue twister. Okay? Now, the middle. Now I'm going to distribute negative Mn. Negative Mn, so negative 1 Mn times positive 1 Mn.
It would be negative m squared, n squared.
Minus 1, and then m squared, n squared. Negative Mn times positive 4.
A negative 4 mn. Yeah.
Minus 4 Mn. And then we're distributing our negative 2. Negative 2 times Mn,
Negative 2 mn.
and negative 2 times 4.
Negative 8.
Okay. Final step, clean up. I see a couple like terms. So let's see. M cubed, n cubed, as is. Then what? 4m squared n squared minus m squared n squared is going to be 3m squared n squared. And negative 4mn minus 2mn. Good. Minus 6mn. And don't forget your minus 8 to end it. Okay. Getting it. That's review, yes? Just trying to show you some of the different pieces here. Now, on the back side, we have one question here. And it is a word problem. Doesn't mean it's a bad thing. I am going to shrink this a little bit so I have room, because it asks us about volume, but I looked at my notes and we're also going to do area. And I think I did area because there's an area problem I put in the homework. Okay. So, a box is to be made out of a rectangular piece of cardboard that is 20 inches long and 14 inches wide. Squares, X inches on a side, are cut out the corners and the sides are bent up. Write an expression for the volume of the box. Are you visualizing here?
No, not really.
Okay, well, let's draw a picture. What are we making this out of? Rectangular piece of cardboard.
Like gibberish.
Okay. There's my rectangular piece of cardboard, yes?
Yeah.
It is 20 inches long and 14 inches wide. So 20 inches long, 14 inches wide, yes? I'm all about pictures here. Squares, X inches on a side, are cut out of the corners. So now are you following what they're saying here? They're saying that in each corner, there's a square that is X by X that is cut out. On each of the four corners. X by X. X by X. Are you seeing that? So we're going to clip away those corners. And then it says the sides are bent upwards. And it's going to form a box. Okay? Any thoughts? Well, okay, so it's a box, yes?
Yeah.
Let's start there. Volume of the box. What do you know about volume of a box? Go into that elementary mind blank.
Is that like
Mind.
length times width?
Uh-huh. In order to do elementary, or it's your elementary volume, yes? Length times width times height of a three-dimensional object there, right? Okay, so we need, if you're taking these corners and getting rid of them, and you're folding these flaps up, I need to know how long this box is. The piece of cardboard is 20 inches.
Oh,
20 minus X.
But then we're going to take those corners out, and we're going to fold it up. And so we take those corners out, and we fold those ends up. Okay? I don't know if I can get this to do justice or not, but there's one corner gone.
So would it be like 20 minus x squared?
2X.
Or would it be 2x?
Wait, no, it would be. Oh no.
It's one of those, so I feel like.
20 minus 2X times 14 minus 2X times whatever.
Are you guys seeing this? Here was my piece of cardboard. I cut out the X's. Now, this was 20, yes? I cut out a square and a square, pretend they're squares. And now, we're going to fold these flaps up. Right? When I fold these flaps up, give me a moment here. It's not great, but it's going to work. My box, it was 20 long, or my cardboard, it was 20 long. I fold these up. What did we take out? What were the boys saying? We took out an X here, and we took out an X here, yes? So how long is that?
20 minus 2X.
It is.
Oh, dang it.
Okay, so this right here, basically I want that distance right there. It was 20. Take out the two pieces. It's 20 minus 2x. So that is my length. What about my width then?
14 minus 2x.
Yeah. The width of this paper, we'll pretend, was 14. You take out an x, you take out an x. 14 minus 2x. So this right here, 14 minus 2x, and that is my width. Excuse me. Now, I need a height. How tall is my box?
It would be x squared or
Just
2x. X.
Just x.
Yeah.
Okay, because we take out an x, we're folding this up, it's just an x. Okay, so I don't really have a good way to show that, but you end up with the height is x. So the length, 20 minus 2x. The width, 14 minus 2x. The height, x. Now, the name of the game today is adding, subtracting, multiplying. Do we get to leave it like this?
Nope.
No. And I'm not, in a normal scenario, I'm not against you leaving it like this, but Savas is going to require you to go farther. What did we just talk about on the front? When you have to multiply three things, pick two, multiply them, and then multiply the third one in at the end. My suggestion is we multiply the two parentheses. We'll worry about the x at the end. Okay, so 20 times 14.
Seems like a lot of work just to find out the volume of the box.
20 times 14 was 280, by the way. 20 times negative 2x minus 40x. Negative 2x times 14
Negative 28x
minus 28x. Minus 2x times minus 2x
plus 4x squared.
plus 4x squared. Now, I'm going to put that in parentheses, and at the end I'm going to write times x, because I don't want to forget it. Clean up in the parentheses. We still have 280. What's 40x minus 28x?
Negative both. Or,
60.
oh yeah, I was adding. Never mind.
I did the
Minus
same thing.
68x plus 4x squared and times x. And what do we do to finish this off?
Multiply that.
You're multiplying that x in. When you multiply everything by an x, folks, don't think too hard. X times 280
280x.
minus 68x times x
68x squared.
plus 4x squared times x.
4x cubed.
And that is your volume. Officially, and I know it's just a formula, what would be our label for volume? How are volumes labeled?
Cups.
No. The dimensions are inches.
Inches squared.
Inches squared would be area.
Is it inches cubed?
Inches cubed. I just thought it was a good moment to throw that as a review in. Okay, now. Okay, real quick, before I finish here. I wish I would have looked up in Savas. I never think ahead about this, but down below here, I have an area that I've done using the same problem, so we don't have to redo any of the, the same scenario. If they ask us about area, okay? Now, area, just area of a rectangle is length times width, right? Now, they might phrase it as surface area, because the surface area of this box would be doing what? The area of this side plus this side plus this side plus this side plus this side, yes? Now, we can do a shortcut here though. If I'm trying to do the area of this box, it's those 6 rectangles added up, yes? Or, think with me, think outside of the box, haha. What was this shape originally? A rectangle, yes? And what did we take from it?
Corners.
The 4 corners, right? Are you following me here? So area, I think I've lost people. Area could be, if we're trying to find the area of this box, adding up all 6 of those sides. What I'm trying to get you guys to look at is the idea that it was one big rectangle minus the 4 corners. What would be the area of that big rectangle? What was my original piece of cardboard? 20 by 14, yes? So how do you do the area of that big rectangle?
We got 20 times 14 times 6.
No, just 20 times 14 for the whole piece. Okay, this whole thing was 20 by 14. What did I take out? 4 corners. So I took out 4 corners. What do you know about each corner? What's the area of one corner? How do you do an area of this corner square?
I don't know.
Think with me, guys. It's a square. How do I do the area of that right there? Area of a square. Area of a rectangle?
Length times width.
Length times width. Area. Come on, guys, help me out here. I'm struggling.
Length.
I am. You can tell me volume, but you can't tell me area. That's what I'm feeling right now.
Eliazi, come on, you got this.
No, but that's the thing. It's not just Eliazi. There are 13 other people sitting in this room besides him that should be helping him. Okay? Area of a rectangle. Area of a square. Length times width. Yes? What are these squares we took out here? What are their dimensions?
X times X.
X times X. Yes? How many of those did I take out?
4.
4 of them. So each corner is X times X. Now I wrote that as X times X. What is X times X? Just what is X times X? X squared, right? So this right here is minus 4X squared. 20 times 14 is 280. I think I just had an epic fail here.
What?
I was trying to just take you the easy way for area. I don't think you guys liked it.
I don't think that was very
Okay. Well, it was easier than doing the long way of, okay, let's do this area, plus this area, plus this area, and adding all 6 areas. Write this down. Remember it for homework. I think it will help you. Okay? Unless I'm way off guard as to what's in the homework, but I'm pretty sure it would help me. Okay. Now, that doesn't help the issue of 3.1, does it? Okay. 3.2 is out there. Do it for tomorrow. We may